everyone. Welcome to another episode of Wearing Flip-Flops. So far, we were talking about a lot of things, but we never dove into AI all in. And this is exactly what we wanted to do today. And for that, we have with us a special guest, Sirish Kumar. Hi, Sirish.
Hey, Ronan.
Happy to have you here. Can you tell us a bit about your background?
Sure. First of all, thank you for having me. I'm Sirish Munipalli, CTO and co-founder of MooresLabAI. I have spent the past 15 years working in the semiconductor industry, building complex silicon systems across research, startups, and large semiconductor companies. So I started my career with FPGA prototyping and emulation and eventually transitioned into verification. I held different roles at Intel, Qualcomm, Microsoft, and hardware startups. And also along the way, I also spent a significant amount of time developing software applications and building AI models from scratch. I'm excited to be here and talk about where semiconductor development is headed and how AI is changing the way we build chips.
Well, really happy to have you here with us, Sirish. So let's start with a very high level, I would call it a naive question. Why chip design and verification needs a different kind of workflow, meaning AI?
Okay. So initially, when we started Moore's Lab, we actually thought of like disrupting the whole stack. But as we started working on several problems, we try to get more focused towards verification first, and then start tackling different stages. So at Moore's Lab, specifically, we don't believe it's going to be fully autonomous chip development yet. We believe it's going to be augmented engineering. By that, what I mean is AI needs to be part of the whole process because semiconductor development, as you know, is too complex and the cost of being wrong is too high. So to take engineers out of that decision-making process is not the right move because if there is any bug or something happens, the tapeout's going to cost like millions of dollars, and that's the reason why we are choosing like a augmented engineering route instead of building a full autonomous chip development environment.
Interesting, because I do hear, some customers are trying, different ways, but it would be interesting to discuss, your thoughts on that. And, if we go back to episode 2 and 3 of Wearing Flip-Flops, we talked to Amazon's Graviton Verification Manager. And at the time, he mentioned that AI is great for scripting. It's great for coverage. It builds environments pretty fast and does some debug. At that time, the debug wasn't fully there yet. Where do you see debug today?
So I partially agree with Claudio. Yeah, I did watch the episode a little bit, but I think if you are trying to use like a simple chat completion API, then yes, yeah, it is a fantastic tool for documentation, scripting, writing coverages, and yeah, maybe getting you to the first 80%. But that's not how we are currently building the tools at Moore's Lab AI. We are taking a completely agentic route, and today most of the people, right, if you ask them about LLM to debug using a simple simulation log or a waveform snapshot, they just provide those two things and like some couple of design files for it, but that's not how a debug can be done. Because if you see a verification engineer, the way they do debug is like they correlate the information across multiple regression runs, compare the failures against specification, understand the RTL implementation, examine if there are any coverage holes, and after building all this hypothesis, they narrow down the root cause, right? So keeping that in mind, we built our debug agent. So by the way, we specifically built agents for all these different stages, whether it is debug or coverage or verification. So I want to talk a little bit about debug agent because that's what Claudio was mentioning in the previous episode, right? So
Sure, please go ahead.
yeah, the way our agents do it is, yeah, the first entry point is like definitely building the knowledge base. Today, literally everyone who is using AI to do chip development, they start with that. We need to have a very solid knowledge base, and apart from that, you also need to
When you're
have
saying knowledge base, what do you mean?
so like you parse your specs, designs, and build a structured database so that the agents don't spend like a lot of cycles in like searching through different stuff that is like very relevant for the debug.
Kind of a vector graph that takes everything in, whether it's a graph or something else, but
Yeah,
you
it's
want
yeah,
faster than
some
reading the
sort of
documents every time.
yeah,
Okay.
yeah. So I will get to that part as well, why we do that. So the other part is like building sophisticated tools, um, like tools that can parse your logs, parse your waveforms, and also like build some sort of mechanism to correlate all this information together. And and in our debug agent, yeah, we do build the sophisticated tools, and we are trying to bridge that gap for the LLM to work efficiently. So it goes through the logs, goes through the waveforms, and it moves you to the point where there is an error, and it tries to backtrack from there and see it why the error actually happened, and also at the same time it will check the knowledge from the spec as well. Once all these things get checked, then it will generate the report.
I'd like to take, a step back more on the high level thing of, the theory of, how things are working today. You mentioned that it's not 100% automatic debug. So what could you
Yes.
expect from, such an ecosystem? And I'm not talking about, your solution or a different solution. Just in theory, what could one expect when debugging with AI?
There are like two ways to look at it. Like either um, you have trust in the AI, or you don't trust it. So right, like you need to have a very good tracing mechanism so that the engineer can verify what the AI has found is valid. So to do that, um, uh, we need to build a very good tracking mechanism and visual representation, which we do, and that's actually helping um, a lot of engineers these days because um, especially this kind of flow, right, that we have implemented is currently being used in the live projects with our customers, and they are seeing like very good results.
Would you say that nowadays it would just automatically debug for you, and you come after a nightly regressions in the morning, and all the hints for the root causes are there, or what could you expect after a nightly regression?
So after a nightly regression, right, we do generate. We first of all we go through the entire regression database of the logs and waveforms. So uh, in the morning, yeah, you get a full report, and you can then debate the results, the issues with our debug agent, and it can take you through like all the steps, like why this error actually happened, and if there is a mismatch in the design and the spec, it will be able to tell you that information clearly. Because
Would it also fix it and rerun it with a fix?
uh, only at the verification level, we don't touch the design code, but the verification test bench, yeah, it can come up with any sequences if you want to further test it, but we currently don't touch the design code because
Okay, I guess we'll talk
yeah.
about, the longer term, where are we all heading? But I wanted to ask you different questions. And that's about, whether there is a barrier to the users or what kind of expertise a user would need in order to, work with AI nowadays.
So I would say, in general, it's becoming more intent driven. Like they don't need to be experts if they are going to use these AI tools that are being developed by several of the startups or the EDA companies itself. They can simply chat with it, as long as they understand the spec and the design well. I'm talking mostly about the verification side. As long as they understand the design and spec well, they can interact with the AI just through chat. If you are trying to develop the tool, that is a different thing. You definitely need like expertise in both on the hardware side and also uh, expertise on AI as well.
So maybe another thing that I'm hearing from different companies. Some
Mhm.
just have kind of a skill library, a bunch of skills for debug and building verification and running tests and what have you. And each engineer can do or use whatever skill he wants, and it's kind of their responsibility. Others have kind of a workflow, let's say CAD or an AI team is building stuff for them. And, I'm wondering which of those do you think works better, and what should be, the right solution for a company in order to best utilize AI?
So yeah, we it is not the first time I'm hearing these issues because we face this with our customers. So I'll tell you how we solved it. Because yeah, we have been seeing these requirements from the customers almost every day now. They have a very good skill library that they have developed, and they have their own custom flows, and that's exactly the reason why we built our tool in a very flexible manner. We are giving out our framework and the whole SDK documentation along with it, and we also have a two-way MCP solution. By that, what I mean is, I'm sure you are aware of the MCP protocol, right? It's a way to interact with skills or like use the tools with the LLM. So
With your permission, I'd like to go back to, skills that you believe are required on the customer side. Um,
mhm.
how do their
Okay.
teams need to be built, or what kind of skills would a design or verification engineer need nowadays?
Oh, design and verification engineers. Okay, so coming to that, right? Like, they definitely need to understand the um, uh, specs, RTL, and um, also like different types of syntax to do the implementation correctly. And apart from that, um, they also need to know how to provide the intent properly to the LLM. I feel that is the biggest thing right now. Whether you take design or verification or debug. So as long as they can give that intent correctly to the LLM, it will do a good job, because LLMs are very good at doing very directed tasks. If at all you tell it to like resolve all the issues in this design and fix the bugs, that is very vague. It
Are
doesn't work well.
there any challenges or common challenges that, verification or designers would hit when, running AI with design? I mean, infrastructure things, AI related knowledge, anything that is, CAD related or just beyond knowing to do verification or to do design. Any challenges that people might hit at this point?
So so those are two different questions, Ronan. So if at all they are trying to build the AI tool within their company, yeah, definitely those
Oh,
are the
maybe, yeah.
challenges.
The
Yeah,
reason I'm asking this is because there's a debate, and
yeah.
it's kind of open. It's a build versus buy
Hmm.
debate. So some companies would say, well, with all the LLMs that are just improving exponentially every day, we should have a team that is doing an
Yeah.
infrastructure that all the company would use. Others are saying we are not experts in building infrastructures. We should better outsource that. So we'll tackle both of them, but I'm asking for, as a first question, let's talk about what's required within a company if they would have wanted to, build the AI infrastructure themselves. What kind of skills do they need?
If at all a company needs to build these kind of AI solutions within the company, they do need access to the LLM endpoints, like either get it from one of the LLM providers, or they can have like a GPU cluster and build their local models. Once that is done, then comes the agentic workflows. Whether you're trying to solve complex problems for verification, coverage, or debug, um, and apart apart from that, yeah, they need to have like some software expertise in collecting all this knowledge and like storing it in some database so that it will be accessible for the LLM. So apart from this, the biggest challenge would be as the LLMs keep evolving, right? Every almost every month there is a new kind of flow, right? Like these days it is skills. Now they are talking about loops. So they need to keep up with the current trends in this new LLM releases, and they also need to change and maintain all their prompts or skills that they have written. So there is like lot of development that goes into this, and I I definitely don't think that is the advantage for a chip company, because they would rather um, do like verification work or chip design work rather than building like infrastructure solutions for AI, right? And that's where the companies want to actually partner or use tools like ours or from the EDA vendors.
So I'd like
So
to,
yeah.
dive a bit into that because,
Hmm.
again, these are things that I'm hearing, and I'm sure you're hearing as well. And when we're talking about build versus buy, there are pros and cons for each side. So obviously, if a company is building stuff themselves, are building stuff themselves, they would have to invest kind of a team.
Yeah.
Can you estimate, how many people would they need in order to keep this machine in place? And I'm talking about to begin with, the bigger enterprises, the Intels, the ARMs, the Apples, the Nvidias, companies that could easily put a team in place and do stuff. So how big of a
So,
team do such
so
companies need?
I cannot put a number on that. It depends how sophisticated you want this agentic workflows to be. So I would, because you need expertise from both software domain and AI researchers, and also the hardware team. It's like a combination of like three big fields. So I would say, yeah, somewhere around like you got to create a different org for this, because as I told you, it's not just a one-time build. You need to keep maintaining this, and you need to make sure that it works across your entire organization. So I would say for a bigger enterprise, definitely somewhere uh, from 50 to 100 people, I guess, like
Okay,
roughly. Yeah.
interesting. I think, from my past history, I was serving a lot of customers at my Cadence days and then AWS. But definitely, when there was the question of build versus buy, some companies appreciated that getting internal support is sometimes more difficult than getting external support with the urgency
Yeah,
and how things are
definitely.
getting treated. But at the end of the day, it seems that it's kind of a financial problem
Mhm.
for at least for the big guys, right? Whether it makes sense or not. And the next question I wanted to ask you, since
So,
it's a finance,
yeah, one thing I want to add to this question is because yeah, we have been facing the same challenges as well, right? When we were talking to customers, the way we are trying to handle this is we are actually providing this base framework. So they don't need to purchase all the tools. They can start with our base framework so that it will get them started. And most of the companies are actually open to that kind of model. And
when
because
you say base
yeah,
model framework, what does it mean?
so it will give you all the foundation for this agentic workflows. You can integrate your tools easily instead of like spending like a lot of time on building all this infrastructure. They can simply write simple scripts, import it as tools, and once they have this flow, they can also integrate our tools into their flow as well. So it is very flexible for them, and we take care of the infrastructure issues as well if there is any problem with scaling. So a
So
lot of companies are adopting for that kind of model these days.
this is interesting, and I think my next question, if you can answer that, and without revealing your secret sauce, but again, when looking at the build versus buy, there is a number somewhere, that the company might say, for this number, I should better do that at home. And
Hmm.
this number may cap, how much companies as yourself, as your company, could leverage kind of on the business. Can you say something, about that? What kind of, is there a silver number or a gold number? How do you treat that?
I honestly don't think it is mostly financial driven, because we have been talking to a lot of customers, right? It's mostly the time crunch. Um, so so in this case, right, it's definitely like if they are able to close their entire chip development sooner, they sometimes yeah don't care that much about the financial thing, right? If at all we deliver results and we are able to show that we can finish this project like 6 months before the deadlines, think yeah, I feel yeah anyone would take that route rather than like building it and maintaining it, right?
Um, that's interesting, but along the way, maybe that's the way it is now. But again, looking into a big customer that could potentially put resources to do whatever they wish. So
Hmm.
along the way, what's the bar that such a customer would have to do again, in the build versus buy, because everyone at the end of the day looks at their financials. Let's say you help them and they can do a project now in half the time, and now they can look at what's going on and just copy and do the same. What do you guys have that would prevent them, or the will to do that, if financially it makes sense? So I don't know. I'm just I want to probe your thoughts here.
So as I told you, the biggest challenge is like, um, yeah, especially the maintenance these days. I don't see maintenance and also the time factor, right? Like I feel those are the biggest challenges um, for the companies to build internally, because uh, if you take any chip development project, right, it it doesn't deal with one tool. Like design uses a different tool, verification has different tool, and there are like bunch of flows, and it keeps on changing from project to project. Because when I was working with in one of these big companies, right, it always keeps changing, and uh, I feel maintenance is the biggest bottleneck for them, and they don't want to do that. And if at all they are interested in doing that, they can definitely start with this base package and like start building their foundation on that, because then they will get like support from both ends, right? uh, where we can come in and we can support, and also they have their internal team that will be building custom solutions. I feel moving forward, um, that will be a hybrid model most of the companies will adapt, rather than like creating like a closed tool within the company. And as history has always shown, right, like yeah, many people try to build EDA tools internally, but yeah, now eventually yeah, they just use Synopsys, Cadence, or yeah, Siemens tools, right?
May I ask, for companies like yours that are providing this product and service, what are the challenges that you see internally in order to be able to best support it?
Yeah. So one thing I would say definitely when we are dealing with the customers is that trust, right? With semiconductor companies, you cannot go wrong. So I feel we have spent like a lot of time with the customers and trying to resolve their issues, and along the way we learned a lot of stuff, and we adapted to their requirements, and um, we started with first designing a very good intuitive user interface so that they can easily interact with the AI. It should not have those um, tough requirements where people need to learn bunch of tools. We try to create a very interactive flow. And coming to the next part, like as you know, yeah, LLMs keep changing like every month these days. So we have like a team very focused and dedicated on that work. Like we try to adapt to the tools as soon as we can. And the third challenge is with the EDA tools itself. Sometimes um, uh, if there is any new interface or API that the tools can provide, that will be helpful. But most of our work is done after the simulation tools, and we also need to support multiple tools, right? Um, because we are not a ADI company, we want to be the intelligence layer around all these EDI tools. So
Got it.
apart from this, yeah, we also need to finish our evals with the customers within the given timeline and like deliver results.
Okay, thank you for sharing. Um, I think I have, one more question about, getting your point of view. You mentioned earlier that at this point, it's not like a closed loop that everything is getting debugged automatically and fixed automatically and get into the regressions, and you still have to have a human in the loop, right? Looking a bit, like 6 months into the future, do you still think that would be the case?
6 months into the future, yeah, I would say the LLMs need to evolve, right? Like, if at all you need to go to such kind of autonomy, um, uh, like recently, if you have seen Jan LeCun's interviews, right? He has given a perspective that reliable agentic systems need to be able to predict the consequences of their actions. So today, what we are doing is we are trying to compensate for that bridge with using this agentic loops, and like having one agent judge the output of another agent. So moving into the future, I still see we do require all the simulations, and we still need a structured data for the LLM to consume and like debug the issues properly. So I feel, yeah, those um, there won't be that big changes yet.
Okay. I think our time is almost up, and we should definitely meet again. But since we're publishing this episode just before DAC, anything you want to say to the audience that would be seeing us all at DAC?
So I feel, yeah, there are like a lot of innovative things that are happening, are going to happen in DAC, and one thing I'm really excited about is the latest development in open source communities, because there are a lot of RISC-V projects that are coming up, and I would like to see a lot of people getting involved in hardware development, and I hope this industry gets disrupted in a good way.
Same here. So thanks for your time. See you at DAC, and see you on the next episode. Thank you.
All